My last vlogging topic and title is all about process safety, right? But this next vlog is related to it because this is process safety information. Actually, this is process safety information is under or one of the components of process safety. So the details or the process safety information like that so that we can manage the integrity and reliability of the operating systems, right? Okay, special or highly hazardous chemicals. Okay, by applying the good design principles, engineering, and safe operating procedures or SOPs. Okay, so when we talk about process safety information, meaning to say we already have a running plant, okay, an operational plant. So that's why it involves processes, okay, a lot of processes to come up or producing or to deliver a product which is an output. Okay, so the product or the products in general could either be in three phases of matter. Remember, in chemistry it could either be solid, liquid, power plant, so you are producing power or electricity. So if you are in a geothermal plant still, you are producing power or electricity by means of geothermal. Okay, like that. Or hydroelectric, same power, electricity will be your product. Okay, something like that. Or if you are in the metallurgical industry, then your company will be producing metals or alloys, combination of different metals like that. Or if you are in the fermentation industry, specifically the production of whiskey, wine, beer, like that. So that's another process, right? So if your product will be a solid, then your processes a lot could either be a physical processes or chemical processes. So it could be a combination of both physical and chemical processes. That's why in chemical engineering, we call that as physical and chemical separation processes. So before going further to this process safety information, we need to understand what is really a physical properties and what are really chemical properties. So, okay, going back to chemistry, if we speak about physical properties, meaning only dealing with the physical aspects. Okay, so meaning not involving a chemical change, of course, because that's physical change. Okay, so physical property only. So if we speak about chemical properties, meaning it involves a chemical change like pyrolysis, uh, burning above 1000 degrees Celsius, for example, okay, or catalytic cracking, okay, involving catalysts in order to break larger crude oil to produce some petroleum products, something like that, right? So those are chemical change that involves the chemical properties. So basically, there are two types only, the physical and the chemical separation processes. Okay, so in chemical engineering, that's what we call as unit operations. Okay, in different processes, of course, for example, if you are producing, for example, only if you are producing rubber, okay, so your plant is producing a rubber, and then you have so many processes there, a mixture of physical and chemical separation processes. So first we have the extraction, something like that, right? Uh, it could be crystallization, distillation, and again, pyrolysis, distillation, something like that. So, a lot. I cannot describe to you all or express to you all the different processes. Okay, so going back to process safety management. So, if your plant is running and operational, so that is called already a process. Okay, and if we are to understand, if we are going to understand the process safety management, then we know first what is our process specifically. Okay, like that, of course, we know the process. And then after knowing the process first, okay, it's the first thing to do. We should know the work equipment that is being used in the process. Okay, the third, we need to know the technology and facilities used in our process. Number four, we need to determine the people behind and the people involved in that process. So we have now four, right? Number five, we need to identify what is our specific methodologies and specific procedures or operating procedures out of it. Number six, we have the work environment or the work area where our processes exists. Again, the first thing to do to understand the process safety management is we need to know what kind or what type our processes really are. We need to know the process first. Second, we need to determine and to understand what are the particular work equipment that is used in the process. Number three, we need to understand what are the particular technology and facilities used in the process, which is related to work equipment in the process, right? Number four, we need to understand who are those people involved in that kind or type of process in producing your product, something like that. Number five, the work environment, okay, and the work area. And the last I forgot is you know what are the particular specific materials that are needed to produce a product. Okay, since this is a process safety management, we need to know the input and then the output. We are not really concentrated to the recovery because, of course, if we recover something, then we need to put back that in the input, right? But usually the recovery will be minimal, something like that, or turned to be negligible. That's why in our energy and material balances in the process, we could automatically say scientifically that input is equals to output directly basing on engineering principle, right? Something like that if we talk about process. Okay, let's start with the input. So in input really, you start with the raw materials. The raw materials could be anything dependent on the product that you'll be able to produce. Okay, raw materials, specific raw materials, you have to understand that also. So we have 6 components already so that we can understand really what is process safety management. Okay, and then we need to connect that to the basic definition of process safety management. Again, process safety management from the word management is to manage the operating systems, okay, the integrity, reliability of the operating system, specifically the handling and the processing of highly hazardous chemicals, or what we call as those chemicals that are flammable, toxic, reactive, and explosive, like that, by applying good principles in engineering, good principles in design, and the safe operating procedure, or the SOPs. So these SOPs are very important so that you could deliver a safer services to produce your product. Okay, and to deliver a quality products after all, right? It should be quality, safety, and productivity goes hand in hand with each other. Actually, these 3 components of a process safety management, which are safety, quality, and productivity, will be given equal priority. Okay, when we talk about process safety management, though a little bit higher will be the top value really is the safety, because you are dealing the lives of the people to prevent injuries, because the people are asset of the business operations for its sustainability, profitability, and of course for enduring for how many years, something like that. So we need to protect the people. That's why sometimes or most of the time safety will be the top priority, which is specifically the occupational safety, health, and environment. Okay, something like that. Okay, so that would be the philosophy behind there. But then, if we try to speak focus specifically in the process, we need to treat equally the safety, the quality, and the productivity. Okay, support with each other, goes hand in hand with each other. That's why we have integrated management system, right? As you can remember, and that's why international organization of standardization occurs. Okay, the independent international standard that set ups or develop okay standards in order to have safety, quality, okay, for the services, for the products globally, okay, like that. So the ISO office headquarter is in, Geneva, Switzerland, something like that. Okay, so there are a lot of standards being implemented by this ISO. So we have ISO 9001 quality management system. We have ISO 14001 environmental management system. We have also occupational safety and health series, occupational safety health administration series 18001 2007, which is lately amended to ISO 45001, which is occupational safety health and management system. So that is the latest and present standard of occupational safety and health management system governed by the International Organization of Standardization, or the ISO. Okay, those are management systems. So we need to understand really that those management systems so that we can really understand this process safety management. Okay, though this ISOs are also very important in construction industry, right? But it is really more applicable in the manufacturing plant, operational plant. What I mean, a plant that is running, okay, producing really the products, meaning 24 hours, chefs work, A, B, C, D, day shift, night shift, middle shift, something like that. So, meaning to say process. Okay, so this really important, the management systems compared to the construction. Construction are focused on the okay, but for this, manufacturing industry operational plant focused more on the process safety management combination of physical and chemical separation processes. Okay, there's a lot. I don't want to mention everything. There's a lot of processes, which is the most important definition. Aside from the other one, manage the process hazards and risks to prevent process events that could lead to catastrophe events. Oh my God! So, what are those terms? Are looks like very deep. No, it's not very deep. It's just common. Okay, when we speak about process events, those are unwanted events, undesirable events that will come up, especially the incident, the accident, the near misses. With regards to storing, using, handling, manufacturing, and movement of those highly hazardous chemicals, so process events, right? And now, lead to catastrophic events. So catastrophic meaning deadly, okay, fatal. So meaning it involves the loss of lives if we will not prevent and avoid this process events. That's why one of the components of the process safety management. By the way, my topic is not really the process safety management. I'm touching only that because process safety information is a part and one of the components of dealing with process safety management. Later, I'll be talking to my part 3 vlogging and live streaming to that later after my workout, my cardiovascular exercise, okay, in the cricket oval. After that one, I'll come back for my live stream or my vlogging, okay? Don't you worry, I have to have my part 3 discussion on process safety management. But still now is process safety information. Okay, yesterday, we're talking about the process safety. So before going further again, we need to review, right? Okay, it doesn't mean that this is only a topic for engineers, okay, electrical engineers, mechanical engineers, like that, electronics communication engineers, or a chemical engineer, something like, or industrial engineer, all types of engineers. This is not a topic for those engineers only, okay, because these are all very important in a process. For example, if you're working in a process plant, okay, in an operational power plant, something like that, or any types of, you know, manufacturing industries you are in now. This is really, really very important, especially, of course, to those engineers, okay, for this management. Okay, process safety information is very important, my friend, or uh, because this is really needed of process safety management. Okay, now before we can come up to our process safety management, I will show you the flow chart so that we can really understand behind for this topic, which is process safety information. Actually, this is really interrelated. Okay, sorry if I can touch others. This is not the example of our topic at this moment in time, but this really related so that we can go further. We need to connect the dots to really understand the topic. We need to connect the dots because this is interrelated with each other. Okay, just like diseases that will come to human being, they are interconnected with each others, right? So there's a side effects for this, another side effects for this, for example. So they are interrelated because they are one system under one physiological system inside our body. Okay, wherein it's operated by different organs inside our body. Just like that, the process. Okay, if we have a one single process specifically, though this process composed of many components before it will produce a product. Process A, process B, process C, process D, and this each process have different quality parameters, safety parameters, production parameters. It depends only the department that will be able to handle in each process A, B, C, D, because there's a lot of, departments, or there are a lot of, employees in an organization. So it depends what type of scope of work you'll be able to handle in each process. For example, if you have 5 processes, process A, process B, process C, process D, then the safety parameters will be considered, the quality parameters will be considered, the production parameters will be considered, the instrumentation and electrical parameters will be considered, something like that. Each department has its own role or have specific activities to be done in each process so that we can come up with our single product, which is this, for example, a cement product, something like that, or it could be a rubber, plastic rubber, or like that, or any plastic materials, for example, polypropylene, okay, HDPE, high density polyethylene, the polyvinyl chloride, the PVC pipeline, or whatever, something. There's a lot of products. I cannot mention everything also here, okay, like that. It's being discussed in chemical process industries, by the way. Okay, like that. I need to show you the process flow diagrams generally, okay, so that we can understand really what's going on if we talk about process, right? Okay, wait for a while. Gosh. Guys, okay guys, okay, let's pause for a while, sharing information regarding, what time is it? Okay, I have 20 minutes more because I'll need to do my cardiovascular exercise later on in the cricket oval. Okay, I maintain it every week. Every week, at least 4 to 5 times. Okay, for maintaining my blood flow circulation. Okay, and my heart health, something like that, to avoid or to reduce the risk of cardiovascular diseases, heart attack, and stroke. Okay, in combination also of the right and appropriate selection of food and drinks. Okay, not only the exercises, I back up that also with ketogenic diets, low carbs and less sugars, something like that. Okay, and with that also I coupled with backup research. Okay, reading, explore, a part of being a registered chemical engineer by profession, okay, and an occupational safety health engineer also in my career. Okay, I need to study every day. Okay, not really that kind of comprehensive study. I will be able to input some information also so that I could share to you guys. Not only that one, because this is my commitment in YT. I have to deliver a content for all of you guys. So as much as I could, I'll be able to express and to share with you substantial, okay, information regarding occupational safety and health science. It could be pure sciences like chemistry, biology, biochemistry. It could be sometimes mathematics or physics, but not more on mathematics because, as I said earlier, I'm not good in mathematics. Okay, I'm not really good at mathematics, but I am okay, above average in English and science. Okay, that's my strength. Okay, so that's why I'm in front of you now. It's not easy to discuss to the virtual platform in social media, right? If you don't have talent in speaking capability, something like that, and if you don't have forte in discussing, example, chemical reactions, something like that, or blah blah blah, or whatever, occupational safety and health. So it's not easy, okay, even though there's no people around me here, but it's not easy also to formulate ideas and information that we'll be able to share with you guys. Okay, going back to the topic, which is processing information, and I have to actually process the information. But guys, I don't have to discuss everything because it will take me a longer time to discuss everything because there's a lot. For example, if there is 1 or 5 examples, then if we have to be detailed enough in discussion, then it will take a long time for me to discuss. I have another appointment. As I said earlier, I have to do my cardiovascular exercise. I have 20 minutes left more. Please forgive me. Okay, and I come back later. Okay. Okay, this is process safety information. I need to write. Okay. Class, PSI stands for Process Safety Information. Like themes. Okay, like that. If you are students right now, I will tell you we should be smart enough to discover the acronyms, the abbreviations, and during your study, we will need to be alert for the clues, hints, and techniques and strategies in our study, right? And then we need to comprehend, analyze very well, okay, before we memorize. If we memorize, then we understand. Of course, because if we just memorize, then we don't understand, it will be lost somewhere along the way during the examination. Even me before, also in my college days, I memorized everything, something like that. Not really everything, but most of the times I really memorized, but I need to understand what are those things I memorized because maybe it will be lost. Okay, and it's very difficult to retrieve if you are just memorizing without what you are memorizing. Okay, so that's the technique of studying. Okay, in order to pass certain examinations. Okay, like that. Especially if you are a scholar right now, you have to maintain your grades, right? Okay, maintaining the grades is not easy. Okay, because me, I can relate also. You know, I am also one of the scholars before in the college days. I'm a government scholar, okay, before in my college days, GSTPE, government scholar, okay, something like that, and I have to maintain grades also, okay, so it's not easy to be a scholar also, okay, something like that, so we need to be alert and smart enough to do some initiatives, techniques, strategies in order for us to study comfortably, okay, at our own pace. Okay, pace meaning PACE, our own convenience, our own comfort, like that, our own time, that's meaning of pace, PACE, okay, like that, at our own pace, okay ba? Okay, going back, oh, I have Skyflex here. Skyflex is good also for diet, ketogenic diet, okay, Skyflex, this is biscuit, okay, and this is having a carbohydrate. Charot. Okay. Ganon? Yes. Okay. PSI. My gosh. Process Safety Information. This is really very interesting because to those engineering students, if you are going to work now in the future, then this will be applicable for you guys. Because after our graduation, we need to have experience related for our specialization. For example, if you're a mechanical engineer, you will also try to have to work in your specialization. Okay, something like that. Okay, so process safety information. Okay, like this. Because process, a lot of engineers will be there, not only chemical engineers, mechanical engineers, electrical engineers, blah, 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 so on. So, okay, industrial engineers. So a combination of engineers will be there, okay, to produce the product. It's not only one field, okay, it's a lot. We'll be combining efforts, okay, like that. Collective efforts of all engineers and other employees also that are not engineers, of course. Okay, process safety information. Okay, like that. Okay, process safety information. Okay, so PSI means process safety information. Okay, very clear, right? And this is one of the components of process safety management, PSM. Okay, process safety management. Okay, so we have to understand really, so that we can understand what we are dealing with. Okay, okay, and I will teach you the technique for this. Okay, techniques, by the way, plural. My gosh. And then also the HAZOPs. Okay, I know I will never discuss too much with HAZOPs. Hazards operability study. I will just speak a little bit because it's part also of process safety management. HAZOPs. Okay, the construction industry will not conduct HAZOPs because they are not in the process. They are still in the, construction stage. Okay, they are focusing more on the risk assessment, job hazards analysis, job safety analysis, and the method statements for the various scope of works in construction industry. But for the HAZOPs, it is for running plant or producing products that involves a combination of physical and chemical separation processes. Okay, so HAZOPs, it's not applied in construction. It's very clear. Okay, if you are safety professionals right now, safety inspectors, safety officers, safety engineers, safety advisors, like that, or safety manager or some consultant or whatever, okay, we are just the same, right? Okay, HAZOPs are not applied in construction industry, okay? Only for manufacturing industry, meaning a running plant or a factory that produce product, okay? 24 hours, something like that. Because HAZOPs is hazards operability study. Operability study. Okay. HAZOPs. Operability. Hazards. See hazards. Okay. Operability. Actually, the root word for operability is operation. Okay, so of course, when you produce a product, there is an operation behind, and the 24 hours is the operation composed of shifts, right? For example, A, B, C shift. It could be day shift, middle shifts, and the night shifts. If you speak about operation, okay. So operability meaning specifically the operation. Operability. Okay. Hazards operability study. You need to study. Okay, like this. Last one will be the PHA. Okay, process hazards analysis. This is the equivalent of GHA in the construction industry, which is the job hazards analysis. Okay, process. This is what we call as process hazards analysis. Okay, one by one I will discuss you a little bit, but I will not go deeper technically because I'm focusing on the PSI now as our topic, right? Okay, because if we cover all, it will take midnight to finish or another day to finish. Okay, for example, if I will have an example how to make a HAZOP, how to make a PHA, and then it will really take a lot of time to discuss that. And I don't have also the whiteboard, and I don't have visual aids to present it to you. Also, I'm purely talking, right? So maybe some of you cannot understand what I'm talking to, but please understand. Anyway, my English and pronunciation is very clear, right? Okay, process hazards analysis. Okay? Okay, class? Okay, process hazards analysis. Analysis meaning it involves analysis, of course, and you have to analyze. When you speak about analysis, it must be a component. Component A, component B, component C, and we need to analyze each as what we call as our analysis for that. Okay, it should be broken down into different components in order for us to analyze properly, and that is called analysis. Okay, that's why analysis and evaluation should go together. Okay, you analyze, then after that you have to evaluate, of course, right? So you cannot evaluate if you don't analyze first, component to component. Okay, something like that. So again, the four K terms of this live stream at this point in time will be the PSI, the process safety information, the PSM, the process safety management, the HAZOPS, the hazards operability study, okay? Because I'm confused with the operability. Actually, when I look at the dictionary, the Webster dictionary, there is no word operability, only operability, okay? Because before, I'm confused with that word. I use operability, but actually it is operability, okay? Okay, operability, not operability, okay? Before I'm wrong. And now I learned because I referred the Webster dictionary for that, okay? PHA, I'm still learning right now, okay? PHA is process hazards analysis, okay? Like this. Okay? So our focus is PSI, ha? Oh my gosh, time check brought to you by Powdered Alaska Milk. Oh, it's 4:55 in the afternoon. Okay? Okay. When we speak about PSI, what comes in our mind? Process safety information. We need to understand about process. Okay? Of course, we need to define what is really a process first. And second, safety. We know safety very well, right? Okay, everybody knows about safety. Okay, that is preventing any harm, okay, preventing any danger or any hazards and risks, so that there will be no incidents and accidents will be happening, and so that there will be no injuries to humans, and there will be no damage to equipment, to properties, and there will be no damage to the environment, damage to facilities, technologies, equipment, and so that there will be no company losses, okay, there will be no permanent or temporary disability, something like that. So those are about safety, and it's very clear in our mind, even though I will not discuss the term safety, right? It's all about prevention of workplace injuries or occupational safety injuries, something like that, or occupational health hazards or health diseases, sicknesses, something like that. Okay, and then process. Okay, process. What do you mean by process? Okay, anybody? I'm talking with myself. Okay, our process is any activity, various activities involving highly hazardous chemicals, okay, or hazardous chemicals, okay, like that. So including using, okay, just listen to the K terms, using, storing, manufacturing, movement, handling of this highly hazardous chemicals, or what we call as HHC, highly hazardous chemicals, in short, so that we can memorize faster. HHC. Okay, these highly hazardous chemicals are referred to as flammable, toxic, reactive, or radioactive, and explosive. So these are the properties that what we mean of these highly hazardous substances or highly hazardous chemicals. When we speak of substances, we automatically mean that as chemicals in the context of process safety. Do not be confused. Okay, when you speak about substances, it involves solids, liquids, and gases. And the chemicals also can either be solid, liquids, and gases. So if we speak about substances, that's a general term for chemicals. Okay, so a hazardous substance, meaning hazardous chemical, something like that. We automatically mean that way technically in chemical engineering, something like that. Okay, not only in chemical engineering but also in occupational safety and health, of course. Okay, under hazardous communication standard. Okay, in something like that. Okay, so that is the definition of the process. It's very clear, right? Any activity involving highly hazardous chemicals or those substances that are flammable, reactive, explosive, toxic, and radioactive, including storing, using, manufacturing. This is what we know as process technically. Okay? Yes, I can learn something. So that is information. Again, and information is a data to learn in order for us to understand something and so that we can apply that in our day-to-day lives. Okay, very formulated my own definition with information because basically information is data. Okay, nobody will argue for me that. Okay, okay, you understand? So this is now PSI. It's very clear. I need to explain each term so that we can understand really what is really a PSI or process safety information. Okay. Now, we go now to the clear definition of PSI. Anybody who can define what is a PSI? This is a very, very essential component of the process safety management that we need to understand. Guys, do I speak too fast? Okay? If I speak too fast, just, object. I Sir Sotero, you're talking too fast. Please make it slow. I can't understand whatever like this. Okay? Wait for a while, I have to drink water. Okay? Please forgive me, guys. I have to end my live streaming now. After 30 minutes, after 20 minutes, sorry. Okay. Going back. Okay. Here it is. Okay. Process safety information is composed of an information on the hazards of the highly hazardous chemicals that are used and produced in the process. It also involves the information of the technology and work equipment used in the process. And I thank you. That is the definition of PSI. Again, as speaking, okay? This PSI or process safety information includes the information on the hazards of highly hazardous chemicals like that. Of course, it is being used in the process, okay, and it is being produced in the process. And then it consists also the information of the technology and the work equipment used in the process, and that is process safety information because the clue there is very important, information. Okay, if you understand the 3K terms, process safety information, bingo, you understand really what the topic is all about. Okay? Now, each information under process safety information composed of so many examples. Let's start with the information to the hazards of the chemicals, right? Used in the process and produced in the process. So I need to mention, I think there are 7 examples for that. Okay? Oh my God, time check. Brought to you by powdered Alaska milk. Oh! Last 20 minutes! Oh my gosh, June, what's happening? I need to do my cardiovascular exercise. Sorry. Okay? And by the way, also, based on my research, the more you do the exercise, the more you will increase your memory also. Memory retention. For example, you are reading books or you are reading in the websites. Even though you read that at first time, all those information will be registered in your brain. Something like that. So you have a very high memory if you have maintained your regular exercises. Okay? Like that if you go to the gym regularly, if you are biking, walking, running, jogging, or doing the aerobics exercise, yoga, or any physical activities that involves the burning of calories, okay, and fats. Something like that. Increase your memory also. Okay? And it will sharpen your memory also, your retention. in your brain is very high, something like that also, okay? So this is very important, right? So even though we are not a students anymore, we need also to learn, okay? Because our world will never end and stop only for working. We don't know we have a better future awaits for us. Maybe you will become a spokesperson of, for example, of the environmental department of the government, right? We don't know really what our future really is. Something like that, and we need to learn every day, okay? Just like me, 3 years or 5 years from now, I will take my master's and then doctorate, something like that. So, in environmental science, because I already started my master's in University of San Carlos, Talamban before, okay, I'm taking the specialization of master's in environmental science because I want to improve my learning regarding OSH and HSE, health, safety, and environments. I did not finish that master, of course, but who knows, I will finish that later on after how many years, right? Okay, but for now, focus only to OSH. Just enjoy what you are doing right now at present because these are the blessings that God gave to us. We need to embrace and be happy and be contented because these are all blessings around us. Okay? Even those small things, big things, then if you take a deep breath, okay, inhale and exhale, and we can see the sunrise, that's already a blessing that God gave to us, right? Agree? And we need to be happy and we will not compare ourselves to anybody else because every one of us is unique. Okay? We have our own talent. Okay? Individually, and we must be proud of and must be happy what we are doing. Okay? Something like that. Going back. So like that, yeah, is a good motivation to all of us. Okay? We can have frustration, insecurity, or doubt to ourselves. Just consider ourselves as unique individual, and we don't want to compete to anybody else. Try to think that we are really special. Okay, something like that. In that way, we can motivate ourselves to be inspired, others, something like that. Also, okay, blah blah blah, so and so. Oh my gosh. Sir June, you are very talkative. Yes, I am. I'm very loud. Okay, my gosh. So, information. Wow. Oh my gosh. What will be happening if, for example, I will become a professor someday in a big university, for example, then I'm very detailed in explanation. My time will be finished. So, sometimes we need to cope up with the hours given to us if we're giving a unit, subjects units in the university to teach, right? We don't need to be detailed all the time. Oh my gosh. Because I want really my students to understand very well. And I need to discuss it systematically, okay, something like that. And so that I could feed them the right information because they are paying me money for my profession, being a professor, something like that. For example, only in that big university, then I have to do my effort to deliver a quality teaching, something like that, right? So we need information. Wow. My gosh. I monitor the time. I'm very conscious with the time. Oh, information on the... But OSHA really identified the chemicals really, that there are at least 130 chemicals under this standard of PSM. Process Safety Management is a standard OSHA standards 29 Code of Federal Regulation 1910.119. So we need to memorize the standard legislation so that we will not be lost. When we implement safety rules and safety regulations, we shall be clever enough what legislation is all about. Okay, because a lot of people will ask to us why we have standard. Then we can say that this is really the standard as per OSHA, as per global safety legislation. It's not enough to say, oh, follow this without any knowledge on that particular standard, okay? Because you are OSHA professional or whatever. So you need to, you need to be clever enough to those legislation. Okay, you have to update every time what are those occupational safety and health standards. Okay? So we don't want to be a decoration. We need to act. Okay? because we can prove through actions how competent we are. Okay, information on the hazards of the highly hazardous chemicals. By the way, class, I shall do this in abbreviation so that we can understand easily. Highly hazardous chemicals. Okay. HHC. Okay? HHC, highly hazardous chemicals. Okay? Used and produced in the process. Okay, self-explanatory, right? Okay, this is the first information we need to understand well. The first information under process safety information that we need to understand is the information on the hazardous chemicals used or produced in the process. So number one, we need to check, identify, and evaluate the toxicity. Okay? Okay, toxicity data. See, this toxicity data, if we need to explain further, a lot become, okay? But we need to be shortcut for the discussing this because there's a lot of examples, right? So toxicity data. Okay. Toxicity data means how toxic the chemicals are to the human health through inhalation, ingestion, absorption, okay, or physical contact. Inhalation, the vapor, the fumes, the smoke, and the gases. Absorption meaning through skin, pores of your skin, in your hand, in your fingers, in your body, in your feet, in your face, something like that. Because our skin has pores, P-O-R-E-S, in our epidermis. Okay, epidermis is the outer layer of the skin. Remember that also, right? So that is absorption, skin absorption. So these are toxicity for the human health. Number three, we have also if it is irritant or not. Something like that. Itchy in our skin, like that, and it's very, having your skin will be, what do you call this one? Too much, I cannot explain further, but when your skin are very, you cannot understand, you keep on like this, rubbing your skin because there's, I forgot the term, sorry for that. Okay, and then we have the skin absorption and then ingestion through eating. Okay, through eating, for example, the particles of the food remains in your hand or the chemicals and you did not put hand gloves and then you did not wash your hands and you will ingest the poison. Okay, you will be poisoned for that particular chemicals and you will be ingested in your body. That is through ingestion. So that these are all toxicity data. Okay, I forgot the term only for the skin because I'm not really I'm not a medical professional. I'm not a nurse. I'm not a doctor. That's why I am not familiar with all those kind of diseases in the skin. So dermatologists can best explain what's that. It's in my mind. I forgot. Okay, never mind. Number two, permissible exposure limit. Okay, PL. I will put that as a PEL, right? Okay. Permissible exposure limit is the quantity or amount of contaminants, or it could be an air contaminants, that is safely exposed to an employee in a matter of 8 hours exposure without adverse health effects. Do I have to say it again? Okay, this permissible exposure limit is the limit, a quantity or amount of air contaminants or any contaminants that is safely exposed to the worker in 8 hours without adverse health effects. Okay, so this is permissible exposure limit, meaning to say it could be a threshold limit value of those hazardous chemicals exposure, TLV. It could be, there's a lot of names for that. Sometimes it will be called as OEL, okay, occupational exposure limit. sometimes PEL here, permissible terms having the same meaning on it tries to an employee will be safely exposed in a 8 hours period of time without adverse meaning harmful effects to human health. So those chemicals, like for example, me, I'm handling this caustic soda chemical. Then at the end of 8 hours, I will not be affected by this toxicity of these chemicals. So this is having the permissible exposure limit, which is adaptable to my human susceptibility and human resistance, meaning I can resist to the kind of hazards for 8 hours, then it's okay. Because the PEL is under passing percentage or under within that range for the PEL, permissible exposure limit. Okay, that's the point there. Beyond that, it's not longer acceptable. So we need to know the PEL. Number 3, oh my God. So, number 3, we have the corrosivity data. Corrosivity data. Okay, how corrosive the chemicals are. Okay, in your skin like that. It's very dangerous. Okay, and then number 4, reactivity data. It talks about how stable or unstable the chemicals really is. Okay, if it is really unstable, then it needs to react with other chemicals and it can cause explosion, something like that. So that's reactivity. Okay, talking about stability and instability of chemicals. If the chemicals are unstable, of course, they need to react before exploding to other chemicals that have higher value of explosion rating, something like that. Okay, reactivity data. It has to do something with concentration in parts per million, something like that. Okay, I think so. Not really I think so, this is reactivity, right? Okay, or talking about the solubility or concentration, really, because solubility is an example of concentration, right? Reactivity data. Okay, number 5, the thermal instability data. Okay, thermal meaning the temperature, the hotness and the coldness of a substance, right, is being measured by a thermometer. Okay, something like that. But this is thermal meaning temperature. Okay, the cloth there is temperature. How hot, how cold the substance or object really is. Okay, it's thermal instability data. Okay, like that. Okay. Number 6, we have the hazardous effects. Hazardous effects of inadvertent mixing of different chemicals. Okay, if you mix chemicals a lot, then we don't know, it produces a very, very hazardous environment, risky environment. Okay, explosion, fire and explosion, something like that. So we need to discover how reactive, you need to determine their physical properties, okay, upon mixing. For example, the boiling point, the melting point, the freezing point, the heat capacity of the chemical, the specific gravity, the density of the chemical, something like that, or the flow rate of the chemical, the viscosity of the chemical, the surface tension of the chemical, like that. Okay, the heat of vaporization of the chemical, the evaporative cooling value of that chemical, something like that. Okay, or the humidity. Okay, how resistant is that for humidity value or level, that chemical, because there are also chemicals that will be altered through high humidity. Okay, high temperature, then the properties of the chemical will change. Okay, because that is physical property. Okay, then we need to cover and seal properly the chemicals so that it will never react to the environmental outside factors. Okay, temperature, pressure, like that, the wind, the air, the oxygen. okay, in the workplace, especially the heat of the sun, something like that. So those are, physical properties, some or environmental outside factors that could affect the chemicals. This is very example in the number 6 information, which is hazardous effects on inadvertent mixing of different chemicals. Okay, hazardous effects, meaning harmful, right? Hazardous is the same as harmful. Okay, general term only, because specific, it could be toxic, it could be reactive, it could be flammable. Those are specific. If the hazardous, that's harmful, dangerous, like this, okay, or risky. They have the same meaning, okay, but we only use hazardous. Okay, hazardous effects of inadvertent mixing okay, of different chemicals. Oh my gosh! Okay, these are under 6, like this. Okay, very clear, ha? Number 6, because we prepare train, I know, but I did not plan to vlog now. Something like this. This is on the spot because I really love to vlog, and then I did not plan this to vlog really. Okay? Because I need to go to the exercise normally in a week, but now I wonder why I start vlogging and streaming, live streaming. Okay? So I need to examine what's missing. Okay. It's gonna be the physical data. Okay. Physical data, okay, a lot, right? For example, the mentioned earlier, humidity, boiling point, like this, density, specific gravity, something like that. Okay, the heat of fusion, really, yes. The thermal conductivity, okay, my gosh, physical data, a lot. If you see your part of and also in the chemical engineer's handbook also, and of sure I forgot. Okay, like this. So that's number 1. 7 examples of that. Read. Okay, red. Okay, so that we can go now to number 2, which is the information of the technology used in the process or for the process. Okay. See, if I will explain this one by one, don't you think I will finish in one day? No, it's not, because there's a lot of, to be discussed. 7 examples, right? And on number 2, oh my gosh, information on the technology. I sometimes write because at least you can have a reference what I am talking to. Information on the technology of the process. This one. Information of the technology on the process. Okay. So meaning to say the systems, computer systems, like that, the data information system, because that is technology, right? And a lot. Okay, it's really also necessary for that's why we have central control room, central control room. So manufacturing plants have that always, because they are handling with the technology and the data information regarding the process. And they will be the one to signal that's really abnormal, then we have to stop, then we need to introduce a remedy, a control measure, so that we can have a better process, so that we can run normally. Okay, and the signals department to department. For example, they will signal the electrical department because there's something there, problem there, something like that. So you can see that in the central control room, or the CCR, data information center, regarding that's technology. Okay, by in the computerized 10 units, computerized units, something like that. You can see there everything, the parameters. Okay, there's a flow chart. Okay, process flow chart, the equipment, the lines to lines, something like that. Okay, no need to discuss that. Okay, information on the technology of the process. That's what we mean here, the technology. Okay, information on the technology of the process. Okay, number one. My gosh. Yes, a process flow diagram. But we need to choose the simplified. So the simplified process so that we can understand properly. Not the complicated or the complex. Okay, simplified. Okay. This is for the technology. This simplified process function is in the central control room also, in the computers, in the screen. They can understand because we have operators there to, to check the data, something wrong, and then they have to communicate what's really go wrong, like that, okay? You don't need to explain that, okay? A simplified process flow diagram, okay? And then, so it could be a black flow diagram, black process flow diagram, black only, by like this, only square, 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 like that, okay? BLOC key, black process flow diagram, okay? Like this. This is kind of a, schematic diagram to understand our various process equipment. Okay? Process equipment, we have the process chemistry. That's why I'll never discriminate other courses, okay? That's why they prefer to hire a chemical engineer most of the times, especially in the manufacturing industry, because a chemical engineer have in-depth knowledge of chemical reactions and chemical processes. We understand really the behavior of the chemicals could either be solid, liquid, and gas. And those solid, liquid, and gas are what we call media. Okay, if one medium, okay, this media, solid, liquid, and gas, for example, your product is a liquid, you're producing a natural gas, something like that. Okay, so we need to understand the process chemistry. So process chemistry involves chemical reaction, how it behaves inside the pipeline. Okay, so if how they behave inside the pipeline, we need to determine the physical properties of the chemicals that will go inside the pipeline, of course. Okay, how toxic is that? Okay, maybe it will be a rupture of the pipeline, it will explode, or it will be exploding the vessels because chemicals are very reactive and we don't have control. We need to study first the physical properties of these chemicals that will go inside the pipeline. Okay, in according to the specific parameters that we will call that as the safety parameters, we call that the temperature, the pressure, the volume, the density, the concentration, the flow. The flow meaning the concentration in terms per hour, in terms per second. For example, cubic meter per centimeter, okay, pound per hour. So that is flow rate of a certain substance. Could it be liquid, gas that will pass on the pipeline? Okay, we need to really understand, okay? Because if we will not control that one, so problem, maybe it will explode somewhere along the way in the line to line. Okay? That's why we need to have records we need to have preventive maintenance for that. Okay? And we need to really understand the process chemistry of those raw materials that will be feeding. We will feed to the inlet and go into the outlet. Okay, so that's why we hired mostly chemical engineers for that. Okay, that's what we call the process engineers. Okay, a lot of manufacturing engineers have its own process engineers and a lot of chemical engineers are there. Okay, I'm not lucky, I'm not there, but it's okay. So process, okay, like this. Process chemistry. See, chemistry, meaning chemical reaction, chemical properties, chemical change, like that. Everything, blah, blah, so and so. Okay? Process chemistry, we need to understand the raw materials and the product. Not only the raw materials, the product also. Okay? That's why we have quality department, quality control department. Okay? We cannot run. Okay? We cannot run the process if it will not pass the certain parameters in the quality control department because, problem of our products. Okay? especially if there are abnormalities. If there are abnormalities on the raw materials and it runs from lines to lines, then our work equipment also will be damaged and malfunctioning someday. Okay, that's why we need to control the parameters. It's in the range, in the passing range. Okay, high quality, something like that. That's all about process chemistry. Okay, number 3, maximum intended inventory. We need to inventory the chemicals used. Okay, inventory, very important also. Okay, if we will not conduct inventory, then if we consume our raw materials, and then how can we run the products all the time? We must have reserve raw materials all the time. Okay, ahead of time. That's proper planning. So that's maximum intended inventory. Okay, we need to do that. Okay, so planning ahead of time for our raw materials. We need to reserve our raw materials so that we will not suffer later on. Okay, so maximum intended inventory. Okay, oh my gosh. Sorry, I will stop this really. Max inventory. Number 4, I love this. Okay, this one is safe limits. Okay, safe limits, meaning upper and lower safe limits. I love this part. Okay. Okay. Safe limits, upper and lower safe limits regarding temperature, pressure, volume, flow, or concentration. This is really the parameters we need to study technically in the process, because our products and our raw materials are sensitive to these physical parameters. Okay, temperature, pressure, volume, flow, concentration. Okay, if you speak about flow, the density will be there also. Density, okay, and then the velocity. You know, velocity goes hand in hand together. The density, velocity, and the flow, they are related with each other. Okay, in the calculations, and we need really to understand that technically in our raw materials, how they behave in going lines to lines in a process A, process B, process C, process D, something like that. Okay, that is safe limits. And the last will be an evaluation. Okay, so this is for all manufacturing industries, regardless of what products you have. All will apply this process safety information. Could it be soft drinks industry, okay, power industry, okay, like that, cement industry, rubber industry, or anything. Still, we have to use this one. An evaluation of the consequences of the deviations. Sorry guys, of the deviations, including the health and safety of people. See, safety is always included in process safety information, including the health and safety of employee. Okay? Because if the lines to lines will have accidents there, okay, where explosion, something, loss containment, meaning the rupture of the vessels or the tanks with chemicals inside, okay, something like that, and you did study very well the behavior of those chemicals stored in the particular tanks, okay, problem. So there will be an accident, right? So that's why we need to have an evaluation of the consequences of the deviations. So deviations meaning what are your findings in that process A, process B, process D, process A. In process A, what are your findings in that particular equipment? A lot of equipment in process A, a lot of equipment in process B. Then you have to troubleshoot and you need to identify what are those, so that you can really know the deviations and include the safety and health of the people, because the people will work there, something like that. Okay, so not all will be automatic. Okay, sometimes, not sometimes, daily ala tool have always people that will maintain the operation, their lines to lines in the production. Okay, then we need to take care of their health also and safety. Then we need to, to study the behavior of those, chemicals that will pass in that lines under that particular equipment. Okay, like that. Okay, so it's really considered in process safety information and evaluation of the consequences of the deviations, okay, including the health and safety of employees all over the world. Okay, this process safety information. Okay, this two only. The last part I will discuss later when I will finish my jogging. Okay. Please forgive me. That is information of the equipment used in the process. There's still a lot of examples also for that. Sorry, my friend. Sorry, I have to end this live streaming. I have to come back to continue my live streaming. Sorry. This is again, I am seeing your eternal voice. If you think you like this video, then you can click the notification bell for some newest updates of Egineer, Sotero L. Nepomuceno Jr., Occupational Safety and Health Engineer, okay, and a licensed chemical engineer. Okay, my topics are all about occupational safety and health, pure sciences, health science, fitness, okay, and a lot of personal vloggings also, and a little bit of singing, personal singing. Okay? If you like, then like. If you comment, then comment also. If you want to share to anybody else, then you can. Thank you so much for watching. Bye-bye. God bless everybody. Bye-bye, babush. Mwah. See you later. Oh my gosh. Are you sure you want to stop? Okay.